Hello, welcome back to the channel. In today's tutorial, we are looking at double summations. Of course, this is one of the interesting topics in mathematics. Under these double summations, we are going to have a question, we are going to solve a question where the summations are 2. In this case, a typical example is what we have here. This is the reason for the name double summations. Under such questions, the first thing to do here is to tackle the first part, then the second part as well. In this case, what I mean is we tackle here first, then followed by this. At times too, we need to tackle them simultaneously, depending on the conditions given. Okay, a question like this. We have J to range from 1 to 5, meaning that A starts from 1 and it ends at 5. So if we have a condition like this, then it means that where we see J, we put 1, 2, 3, 4, or 5 there. But the relation here is that we are multiplying I by J. So it means we are going to have I times 1 plus, because of the summation, I times 2 plus I times 3 up to I times 5. And the results are the ones presented over here. So I times 1 gives us I plus 2 gives us 2I, I times 2 gives us 2I times 3 gives us 3I, up to the last one, which is I times 5. That gives us 5I. So the summation of all these results gives us 15I. The first part of the condition is satisfied. Then we need to move on to the second one. I ranges from 1 up to 6, meaning I starts from 1 and ends at 6. In this case, we are going to make a substitution at where I is. So when I equals 1, then we are going to have 15 times 1 plus 15 times 2 plus 15 times 3 plus 15 times 4 plus 15 times 5 plus 15 times 6. And 15 times 1 gives us 15, 15 times 2, 30, 15 times 3, 45, 15 times 4, 60, 15 times 5, 75, and 15 times 6 giving us 90. So the summation of all these results gives us 325 for the double summation. This particular part here is applicable in computer programming, so especially for while loop and do while loop. So let's look at a different question under this one. So we have a second example here. This case, we have our double summation with the first part I equals to k minus 1, and k is equal to 1, and k ranges from 1 to 2. In this case, our I will take a value from k, but our I will end at 2, meaning when k is equal to 1, then it means that our I will be equal to what? 2. In this case, for k equals 1, I equals to 2. So for k equals to 1, I will range from 1 minus 1, which is equal to what? 0. So we are going to have our first part to be 0 plus 1. So we are going to have 0 plus 1 followed by 1 plus 1 and then 1 plus 2 because our I ends at 2. Great. So when I equals to 0, when k equals to 1, I will range from 0 to 2. And that is what we have here. Moreover, for k equals to 2, then we are going to have I equals to 1, 2. That is great. 1, 2. That is for k is equal to 2. We are going to have 1 and 2 with the exclusion of the 0. So when we substitute here, we are going to have 2 plus 1 then 2 plus 2, and that gives us 3 plus 4, and the result is 7. So because it's a double summation, the results of these two conditions gives us some 1 plus some 2, and that is 6 plus 7, which gives us 13. Now let's look at another interesting aspect of this one, which is a double product. In this case, we are considering products of two products times products. So we have a question on double products, and the first part of the condition is j is equal to I plus 1, and the relation is 2 exponent I plus j, and j ranges from this to 3, but I is equal to 0 and it ranges from 0 to 2. In this case, we take a condition from here and a condition from here and substitute it into our relation. So for I equals to 0, then we are going to have 0 plus 1, which gives us 1. Then I ends at 2, so we are going to have 1 plus 1 again, and we are going to have 2. I ends at 2, so I equals to 2 will be here, we have 2 plus 1, and that gives us 3. So when I is equal to 0, j will range from 1 to 3. So let's substitute this one into our relation. So we have 2i, and I is 0, so we are going to have 2 exponent 0 plus j, which is 1. Then when I equals to 0, 2 exponent 0 plus the next one, which is 2. I equals to 0, 2 exponent 0 plus the last one, which is 3. 2 exponent 0, any number raised to the power 0 is 1. So in this case, we have our 1 plus 1, which is 2. 1 plus 2, which is 3. 1 plus 3, which is 4. But because it's a product, we need to multiply all the 3 here. The 3 numbers here, so 2 times 3 times 4, which is 2 times 3 giving us 6. And then 6 times 4 giving us 24. Now let's take the second part. When I is equal to 1, then we are going to have j to be equal to 1 plus 1, which gives us 2. Then I start from 1 to 2. So when I is also equal to 2, you are going to have 2 plus 1. So j will range from 2 to 3. And that is what we have here. Now let's substitute it back. So we are going to have 2 exponent I, which is 2 exponent 1 plus 2, because j starts from 2 and ends at 3. I is equal to 1, j is equal to 3. So we are going to have 2 exponent 1, which is 2 plus 2, which is 4, times 2 exponent 1, which is 2 plus 3, which is 5. 4 times 5 gives us 20. I start from 0 and ends at 2. So this is the last part. For I equals to 1, j will be equal to 3. Sorry. So we are going to have, so here is 2. For I is equal to 2, j will be equal to 3. So you have 2 exponent 2 plus 3. And that is what is here. And we are going to have 7. So the final result is the product of the first one times the product of the second one times the product of the third one. So we are going to have 24 times 20 times 7. And that gives us 3,336. Okay. Another example of this form is a combination of a product and a summation. In this case, we are combining a summation and a product together in a relation. So for I equals 0, we are going to have j to be 0 plus 2, which is 2, but j ends at 4. So 3 and 4. So when I equals to 0, j is equal to 2, 3, 4. So we substitute this into our relation. So 3i minus j. So the first one, 3 times 0 minus 2, 3 times 0 minus 3, 3 times 0 minus 4. 3 times 0 is 0, negative 2, so negative 3 for this, negative 4. And the multiplication of these three numbers gives us negative 24. Now we take the next part, so product 2. For when I equals to 1, we are going to have j to be equal to 1 plus 2, which is 3, but j ends at 4. So we are going to have 2 plus 2, which gives us 4. we are going to have I when I equals to 1, j is equal to 3 and 4. So substituting this, we are going to have 3 times 1 minus 2. So sorry, this one is not part. So you have 3 times 1 minus 3 rather. Then times 3 times 1 minus 4. So you are going to have 3 times 3, which is 0. 3 times 1 minus 4, negative 1. And negative 1 times 0 is 0. For the last part, when I equals to 2, j is equal to 4. So you have 3i minus j. So 3 times 2 is 6 minus 4, which is 2. So we have a combination of a product and a summation. So adding the products together, we are going to have product 1 plus product 2 plus product 3. So we are going to have negative 24 plus 0 plus 2. And that gives us negative 22. Thank you, and don't forget to subscribe to our channel.